afternoon to all of you who are joining us. Good afternoon to those who are joining us from India. Good morning to those who are joining us maybe from Europe, and a good day to those who are joining us from the rest of the world. My name is Samrat. I am working for EURAXESS here in India, and it's a great pleasure for me today to open this webinar, because this webinar is part of our celebration of our 10th anniversary of the EURAXESS India Science Slam. So what is the EURAXESS India Science Slam? Maybe some of you have not heard about it. That's exactly why we're doing this webinar, so you will know much more about the competition which we're having, our annual flagship competition. And we will also give you a very nice overview about science communication, how you can increase your impact as a researcher by using science communication skills. And we have lined up an excellent list of speakers today. I will introduce them to you very shortly, but they are very great science communication trainers and they are researchers. They love science communication and they will also transmit that loving feeling to you today. Be sure it will be a very exciting webinar. We will have a lot of fun today. Right. So without any further delay, I would like to pass on the mic to, I would say not the grandfather of the EURAXESS India Science Slam, but one of the co-fathers of the Science Slam, Arnab Bhattacharya, who has been with us on this journey for 9 years. He has been literally there from the beginning, and he has been part of this workshop, of the science communication workshop since its beginning, right, Arnab? And it's a great pleasure always to have you. And Arnab, just to introduce him briefly, he's the Center Director of the Homi Bhabha Center for Science Education. He's a professor at the Department of Condensed Matter Physics and Materials Science at TIFR Mumbai. Arnab, great pleasure. Let me maybe also introduce the other panelists quickly before I hand over to you. It's also a great pleasure for us to have Sarah Iqbal with us. Hi, Sarah. Sarah is an independent researcher and science engagement consultant. She's doing a lot of exciting stuff around science communication across India and internationally. So we're very happy to have her with us. And she will today tell us a bit about how to engage with the public for greater impact. Also with us is today Siddharth Kankaria. Hi, Siddharth. Good afternoon. Thanks for joining. So now Siddharth is a communications and program manager at NCBS Bangalore, and he's also the founder of the SciComm Club. So very interesting to know, Siddharth, what you're going to tell us today, and what is this the club you have founded, and what are you doing, and how you can, help our audience to know better about science communication. Our next speaker is Priyanka Das Gupta. Hi, Priyanka.
Hello, hi.
Yeah, and Priyanka has a very special relationship with EURAXESS and the science communication series we're doing with Science Slam. She's at the moment a communications marketing fellow at CERN in Geneva, Switzerland. But more for us, she's a former winner of the Science Slam 2017, and she's been an ambassador of the EURAXESS in the Science Slam since then. She's also one of the moderators and trainers of every year of our Science Slam finalists. We will also have Soumya Silori, who is a winner of the Science Slam with us a bit later. She will tell you about her journey as a Science Slam finalist, and of course, that she won the competition in 2020. She will tell us a bit about that, what it means to be a Science Slammer for the EURAXESS Science Slam. Okay, that's it from my side at the moment. Arnab, the mic is with you. Please tell us how to make research more fun and accessible, and what is this EURAXESS in the Science Slam all about?
Great. So thank you so much, Samrat. Welcome, everyone. We are going to have fun talking about science. And maybe what I should do is quickly share my screen. There we go. So I hope you can see my screen right now. And we're going to we're going to take the science we do in our labs and wherever you're doing it and take it out to the public and make it fun and accessible. And you can, send me an email anytime you have questions which are not covered here. This is going to be a rather short thing. And unfortunately, it's online, but it's good. We can, reach out to so many people all over the world. So this, as you know, is the year where we are finally going back to doing this in person. We're going to be back doing this person. Of course, the Science Slam is still online. And in principle, whether it is online or whether it's person, the basic things are always the same. And even all the years, the entry that you will give us, hopefully all of you who are attending, will be a video. And we're going to watch it online. So some of these things have, are important in both formats. Now, you want to convey what you're doing in the world of, science. By science, I'm going to cover everything of science, technology, engineering, mathematics, what have you, to people who are not in the field. We are sure you're extremely excited about what you do. How do you convey that excitement to the rest of the world? And, much of this is common sense, but let's go ahead. How do we go from this? How is the video that you submit different from the live finals? I am a scientist. I'm a tinkerer. I'm a science communicator. I run Chai and Y, and this is my 9th year here. And I love to do the science communication workshop, which actually goes beyond the slam a bit. It's not just the slam. And in case you're getting, you think you're not going to survive 20 minutes, here is the summary and the conclusions. You can go to sleep after this if you like. In any form of communication, you must understand why, the purpose of communication. That's your strategy. You may have done work in the lab. If you're presenting this at a conference, you're presenting this to a thesis committee, you're presenting it asking for a job, the purpose is different. And none of us, we are human beings, we have grown up as we were kids. We love listening to stories. We do not like listening to data. We do not like listening to experiments. We want stories. So you have to tell a story. And a good story is what I call a logically compelling story. It's a story where you want to hear what is coming up next. And for this, everything else that you do is secondary. But the main thing is, do you have a good logical thread that runs to your story? And beyond that, of course, it's style. And style, I would summarize it as controlled enthusiasm when you're speaking. Of course, when you're writing, it depends on whether you're writing a report or a thesis or a book chapter or what have you. But speaking, you've got to appear that you're a human who's excited about talking about whatever they're talking about. Controlled enthusiasm. Okay. So moving on from there, if you look at it historically, any communication system has just 3 parts. Somebody who's sending a message, somebody who's receiving a message, and in the medium is what is the channel, the medium, right? And whether it is animals, humans, formal, informal, business, science, whatever it is, there are these 3 elements. You figure out what is the elements that you have, optimize them. And, if you're, for example, a researcher publishing a paper in a journal, you're the author, the reader, the unknown reader whom you don't know is going to read that. The medium is your journal article. If you're a researcher in grad school, you're a PhD student, there's a thesis committee that's listening to you, the medium is your dissertation, right? And in the Science Slam, you are an enthusiastic presenter. There is a non-scientific public audience, and you have 10 minutes to present yourself. That's the medium. And that's what we're going to try to have fun with. So now, of course, you can look at many things about, why do we present scientific results? How do we do it? Should we write? Should we speak? Always ask yourself, and this is not beyond the Salam, of course, is it accurate? Is it complete? Is it logical? Is it clear? Is it compelling? Is it needed? These 6 things, whether every sentence you write, think of this, is it, this is what will guide you to write effectively or present effectively. And of course, none of us ever managed to do this in one shot. You always do it, you redo it, you iterate it, you revise it, do something, and we'll go through some of these pitfalls in the process. Now, of course, science isn't done in isolation. We have to talk about what we do, and there are formal ways of doing it. You write journal reports, you go to conferences, etc. And there are lots of informal ways of doing it. And that's what we are going to look at. You can make videos over YouTube. There are these Pecha Kucha 2020 formats, and there's a Science Lab. Now, writing, I will just cover it in one thing. Just remember that in most cases, when you write things, especially papers, since most of you are here for science communication, you have no idea on who is reading it. You can't even, unlike a talk where there's an audience, you have no idea who's reading your paper, which means the unknown reader never gives you any feedback on your writing, unless somebody can say, sir, I didn't understand, something like that. Nobody raising their hand and asking you what it is. But you want as many people as possible to read it, and even better to cite your work. And which means the more friendlier your writing is, the easier it is for people to understand it, and more likely that they will say, let's talk about this. And things like the Science Slam, the informal methods actually help you understand your own work better and eventually write better. Okay. So now, of course, we all do this last minute. We have, the day before or something, I need to give a talk, I need to present something, I need to record this video and submit to EURAXESS. What do you do? First thing, in my mind, you decide, what am I going to do? What is the time allocated to me? And within that, there are things that I must say. And this is, even if I'm given only 30 seconds, I must say this. Even if I'm given 1 minute to 5 minutes, 10 minutes, I must say this. There are certain things, if I have the time, I would like to say. Okay, those are the secondary things. And then there are a lot of these, nitty-gritty details about how I prepared the solutions for the experiment, or, what went wrong or something else, which I will not say. Even if I have an hour, I will not get into it because there are more important things to do. So must say, which is, even if I have 30 seconds, I will say this. Stuff that I would like to say and stuff that I will not say. Once you break up these things, you will eliminate the redundant parts, focus on the important parts. And know your audience. Please remember, whether it is a science slam, whether you're at a conference, and mostly you'll be presenting things at conferences if you're researchers, the audience may be tired. This is happening in the evening. The audience can read. So anything you put up on the screen, they have read it before you said it, right? Sometimes at conferences, people have gone through the abstract book, but many people haven't. They've just come there, they've landed up. They are thinking, why should I listen to this talk, right? I could be sending a message on WhatsApp. I could do so many other things, If they are not experts, you have to get their attention the first 2 minutes, because otherwise they will tune off. If they're experts, they will also tune off, but in 5 minutes. They'll give you a little bit longer rope, but not very much. Which means your beginning of any presentation is very crucial. Of course, the rest of it is also important. The beginning is really important. So my suggestion is focus on the first 2 minutes. If you plan this well, it's much, much easier. And remember, before you have spoken a word, there's lots of evaluation that's already gone on. People have already been put into a mood by the previous speaker. If the previous speaker had bored them to death, they are in one kind of mood. If the previous speaker has presented something so exciting, they're still, wowed by it and are recovering from that. Right? They're looking at, if you're giving a talk, not for the Science Slam, you have a template. Are you recycling one of Microsoft PowerPoints or Keynotes, really boring standard ones? No, please make your good one of your own. How much clutter is there on your opening slide? Have you tried to pack 100 co-authors and, funding from this and that and everything in the opening slide? Are you fumbling with a mic? Can you hear me? Can you hear me? Is this okay? Are you taking a laser pointer and, sort of going it around all around the room with that? Are you looking confident? Are you looking scared? Oh God, I have to give this talk. I wish I didn't have to do this, And, if you need a glass of water, please drink a glass of water, etc. Don't appear very nervous when you get onto stage. Then never, ever read the title. Never read the title. Paraphrase the title. Your title is already there on screen. If it's on the conference, most probably the person introducing you will say, the next speaker is going to be Arnab Bhattacharya, and he's going to be talking about monolithic phase-locked anti-guided diode laser arrays. Okay, I made that up. Well, if you come and say, good evening, my talk today is on monolithic phase-locked anti-guided diode laser arrays. I mean, guys, you've not told me anything new. I just heard that from the thing. I didn't understand that. Now you're telling me I didn't understand that. On the other hand, if you say, hey, you know what? Everybody wants to get higher power from a laser diode. And guess what I've done? I've taken different laser diodes and put them together to form an array. Not just an array, but an array where all of them are in phase, a phase-locked laser array. And that's what I'm going to be telling you about. I've said the same thing, but in a different way. Now, how do I do this? I actually write down what I will say. I write it down, pen and paper, not on a keypad. I still believe in writing with pen and paper. I write it down what I will begin with. And then I say, oh, you know what? I forgot to say it was phase locked. I forgot to say it was this. Now I'll scratch it out, write it again. And then I don't mug it up, never mug it up. I tear that paper up and throw it. Okay. But I know when I get there, I know what I will say. I know the important points. It really helps. Okay. Remember, the audience is always, they are ready to get onto WhatsApp and check their messages. You have to keep their attention. So don't, if you have, the magic sauce, the secret thing that you want to tell them about, tell them in the beginning. Don't wait for it to come in minute 15 because you may never get there. In general, keep it short and simple. Keep, even if you can get it, you cannot tell us about your entire research in 10 minutes. Don't try to. Tell them a few points, but tell them well. Tell them what you will tell them about it, and hey, at the end, say, listen, this is what I told you. That's what works for most conferences, at least. Okay. All right. Thank you. This is how most talks end. Just think about it. How many times have you seen a talk end with a thank you? You absolutely need a thank you slide. Sometimes it has flowers or some decoration at the side. Otherwise, people don't know how to clap. Other people need to wake up and all, right? So you need this thank you slide. This is a complete waste of space. Do not do this. Do not do this. What do? You never have a only thank you slide. Remember, if you're at a conference, when you end, the thank you slide is what remains on the screen. Then somebody says, okay, are there questions? So that's slide. Unless you move to a thing to answer a question, that is what is there. Keep some useful information there. At least state what were you working on, what was the conclusion, put your email address again, put some pictures, whatever. Don't end acknowledgements. You provoke some questions with that thing. Don't use just a thank you with some flowers, please. Okay. Now, especially for online, it's important that you choose fonts that people can read. And please remember, in today's world, the possibility that somebody is listening to you on a mobile phone is great. So, make sure that even if it's on this size screen, it's legible. And there are some fonts which are clearly much better than other fonts, especially for online clean fonts without these serifs, Seago, Roboto. There are many of these standard fonts. Don't use Times New Roman and these really fancy, cursive ones. Use large lettering, etc. Okay. Also, be very careful about the color that you use, the contrast that you have with the screen. Don't be too creative with your colors. Don't, it's really terrible. I know you can't see this, but let me tell you what is happening. If you know I cannot see this, why are you showing it to me? Spare the people that, show them what they can see. And if you're in the STEM field and if you're showing data, this is one of my, really pet peeves. I get really upset when people do this. That is, you must always label your axes. Okay. If you're showing a graph, the axes must have labels. Otherwise, it is meaningless. All right. That was a bad joke, I know. Okay. Now, of course, the other thing which is disastrous, especially for online, and I don't know how good my network bandwidth is, whether you can see it, is animations. I mean, there are all kinds of animations that are available in, PowerPoint, Keynote, Google Slides, and all these things. But the best thing to do is use a simple appear and don't try all the fancy things that, they allow you to do. And especially for online things, please minimize animation. It's not needed at all. And remember Murphy's Law, things will go wrong. Test out everything beforehand and be prepared for a Science Slam-like thing to be able to talk to people without anything at all. Just get the story across. And often that comes out so much nicer. Informal presentations, informal ones as well, always spell check. I mean, today, most softwares will give you a little squiggly line telling you that something is wrong, but of course, look at it carefully. I use a lot of chemical formulae, which are all spelling mistakes as far as software is concerned. So you've got to be careful. Now, remember I told you at the beginning, what you need is a nice story that has a logical connecting thread that goes through it. So what you need is a connecting statement. So it's not that you show a slide. Okay, next slide is going to be this. You show a slide and you say that, okay, now you saw this and you must be wondering, where did that peak come from? Let's look at that a little bit in detail and go to the next slide. Or, well, you see this. Now we were wondering, why did this? Is there any other way we could prove it? So we thought, instead of doing only X-ray analysis, we will also do some Raman scattering. Something you have connected to the next slide. Okay, and remember that you often need to build in gaps, especially if you're doing this in now. I can't see any of you, which is kind of a little difficult. But if you're looking at there's an audience in front of you, look at them. They are also human. You're human. Look at them. Smile. Make eye contact with somebody. Take a breath. It's okay. If you can, especially for a Science Slam, you can put a little bit of humor, but be careful. That must be correct. And the most effective presentation tool is yourself. You can do this, and always practice. You should have you should know that at slide 7, I will be at 5.5 minutes in my talk or whatever else, you should practice this. Now for online presentation, again, remember most people are watching on laptops or mobiles. It's better to use the widescreen ratio, but do not fill up the slide because generally what happens is the speaker's video goes in some corner, the top corner, often or the bottom corner. So don't keep the lot of important stuff over there. Use clean fonts. Sometimes I would say don't even use slides. Convert them to a PDF, which is much easier to access, much quicker when it uploads. and number your slides so that when people want to give you feedback, they can say, okay, in slide 17, you told me this. Can you go back to this? And, periodically do check with your audience, especially if you can't see them, that, what I call the all is well check, that, hey, can you hear me? Am I too fast? Am I too slow? Do you have a question at this point? Okay. Of course, today I have been given only a very limited amount of time. So I will not take this pause, but otherwise I would have if we were doing this thing. Now let's go back to the beginning and say, okay, look, that was all good for general science communication. I'm going to look at a science slam. A slam is this short format. It's engaging, it's fun, and it's wow. You want to get the wow. Okay. How long is it? It's 10 minutes. Now, 10 minutes is a long time in your life. Okay. You look at any advertisement on TV or radio, those are 30-second ads. They manage to tell you what they want to tell you in 30 seconds. 10 minutes on stage can be a very long time. But it can also be a very short time, because if you make mistakes, there is not enough time for correcting. Remember, it's a slam. It's not a talk. Please don't go prepared to give a talk. Okay. The pre-evaluation which happens, the way you come on stage, are you going to come walking on stage this way, or are you going to come jumping on stage and say, hey guys, I'm ready with my slam? Okay. That's much more important. Choose this is not a scientific journal paper where you have to say that, the title is a formal science title. You can make a funny title out of it, or a short keyword title which connects to your top. The opening is vital. And the most important thing is, remember, it's not me or Samrat or Priyanka or any one of us who are going to judge you. Okay. It's not the scientists who are going to judge you. You're going to be judged by the audience. The audience are lay public. They're not experts in your field. And what have they been told? What do we tell them? We give them 4 metrics for judgment. What are they? One is accessibility for non-experts. Did people understand your science? What were you talking about? 2 is the conceptualization, the structure. Was there this logical thread going through it? Was it structured? 3, was it the style? Was it entertaining? And of course, finally, the originality, how creative, have everybody does the same thing to present this topic, or you've done it in some cool way. So these are the basis on which you're evaluated, and it's by the audience, not by experts. So remember that. Now, even for the video entry, please go beyond just making a PowerPoint presentation. Please do not make a PowerPoint presentation. It is a precursor to a live event. We want to select people who are going to come and perform live. You are live. You can dance, sing, jump, do some experiment. Show how excited you are. You are certainly excited about the work you're doing. Let that come out. But remember, it's not an item number from a Bollywood movie. The science must come out. What is your key message that you're trying to get out is important. Okay. Now some tech tips. Don't overdo the thing. You don't need fancy things to make a video. A mobile phone video is good enough. The only thing is, do not hold a mobile in your hand. You will, jiggle it around, or your friend will jiggle it around. Use a tripod or put it somewhere where it's stable, because otherwise you will not get a good video. For videos, the audio and the lighting are very critical. If we can't hear you and we can't see you against the background, that's the end. That really puts it down. You may have done an excellent job, but if we can't hear you, can't see you well, it's the end. Sometimes you might need a PowerPoint slide. I agree. Some concept, I want to show a picture of my apparatus. I want to show something happening. You need a PowerPoint slide, but don't use too much of it. Don't over animate. And please, this is not a movie production. Don't do a crazy video edits with, 5 videos inside each other and some fancy effects and background music and all that is not needed. Okay. Just keep it simple. Don't want the fan that is so loud in the background. That certainly we don't want, but keep it simple. Now, again, what is the difference between this video entry and the live thing for those who make it to the final, right? Again, don't use a PPT. It's a live event. You are live. You can do the song, dance, jumping thing, which you probably, really can't do in a video. You can do it much better in person. Main thing, what is your key message, right? How will you capture the audience's attention? You can also engage the audience. You can make it interactive. You can say, you know what? I think the lady out there in pink, she has probably got this question. I know you know the answer. Isn't it this? Oh, it's not. Okay, sorry. I made a mistake. All right. Okay, let's go ahead. Maybe we'll ask somebody else. Yeah, maybe. Yeah, you're stupid. We'll ask somebody else. Okay, whatever. So add some humor, add some irreverence, and be prepared that people are going to ask you all sorts of very crazy questions, not depending on your research. Okay, people are in the mood to have fun, learn some science, but to have fun. And what's the best way to prepare? People keep asking me this. How do I prepare for this? Coaching class to nahi hai, no? There is no coaching class I can go to. Okay. Watch previous slams. They're all on YouTube. Watch them. Watch some TED Talks. See how people do it. If you need some tips for humor, go to PhD Comics, XKCD. They're good, geeky, scientific humor, but appropriate humor, please. Don't get into political humor and all, which some people may not like. But remember, you don't have to be a stand-up comedian. You be yourself. That's the most important part. Be yourself. It is your science that has to come out. That's the main thing. And practice, practice, practice. Okay. Thank you. All the best for your presentation. Well, I said I should not do a slide like this, so I should at least say this. All the best for your presentations. I'm happy to take questions, comments, feedback now, later. You can send me an email. You can contact me on Twitter. And I used to give something called a BAT talk, which we did when the communication workshop was a day-long workshop. And we'll send you the slides of this anyway. I think all of you will get these slides. So you can look at these links. There are some very nice links available on the web on, academic presentations. Okay, with that, I think that's the end. Thank you so much. And I will then stop sharing. And I hope I've kept to my time.
Yes, you were really very good this time, Arnab, I have to say. I'm surprised. It was very concise. And yes, Arnab already gave you the gist of what we're looking at for the Science Slam, and of course, how to do a good presentation. And especially when it comes to Science Slam, you can really go to the videos, entry videos of the finalists of the previous years on our YouTube channel. We will share the link with you, and then you can get a very good idea about what we are looking for and what the judges and the jury is looking for. And then we hope to get a lot of videos from you guys. Now, next we go to Sarah. And Sarah, you are right now, where are you based?
I'm in Delhi.
You're in Delhi, okay. So Sarah is in Delhi, Arnab was in Mumbai. So from Mumbai, we moved to Delhi. Sarah, it's a real pleasure to have you with us. We're very excited now to hear your talk, and please, the floor is yours.
Thank you so much, Samrat, and I'm really delighted to be here to India for many years, and I'm really happy to be here. And I thought, because I will. Am I breaking, Samrat? Is my audio all right?
It was breaking for me. I'm not sure for the others.
Yeah, I think it's breaking a little bit.
Yeah, it's. I can see my screen is free.
Yeah, Sarah, your audio is getting interrupted.
Maybe Sarah, if you could try to switch off your video. Oh, we lost her. Oh no, you stopped. Oh, you're back. Sarah, now you're muted. Yeah.
Is it okay?
Yes. Yeah.
Okay.
Perfect.
Fingers crossed. No technical hitches. Very sorry about that. I thought, since I'm new to this community, I will maybe start by telling you a bit about my journey, and then maybe I'll talk a little bit about public engagement with science. Again, like Arnab mentioned, 20 minutes is not going to be sufficient to really pack all that there is to talk about public engagement, but I'll try my best. And so started as a researcher, as a student of science, and then went on to do my postdoctoral research in life sciences. And then while I was finishing up my postdoc is when I got really interested in the interface of science and society. And I wondered what was really happening back home in India in this space. And that's when I came across this role at DBT Wellcome Trust India Alliance, which was first of its kind for the organization. It was called the Public Engagement Officer at that point. And while I really did not know much about public engagement when I joined them, I had done a lot of science outreach and science communication type of work during my PhD and postdoc. So that kind of came in handy, and that helped me land this job. And then I was at India Alliance. I kind of set up the organization's communications mechanisms. I set up their public engagement program. Also worked on a couple of skill and capacity building programs in research, biomedical research, and also in science communication. And I have to say a lot of it was, a lot of trial and error, and a lot of experimentation in the true scientific spirit. And just as of last year, I left India Alliance and have since been working as a science engagement consultant. I'm currently focused really on finding ways of how we could improve public communication and engagement with science in India, and what are some of the policy and programmatic interventions that can be brought in to build capacity in science communication, to build practice in science communication and public engagement, and so on. So I've been doing a whole variety of things on that front, and as before, the exploration, experimentation, and sense making continues. And I don't claim to be an expert at all. I'm more of a student of public engagement. So I'm going to share my experiences and my encounters with public engagement more than anything else. And this is just kind of a snapshot of the kind of work that I have dabbled in so far. I've been part of, and I've also conceptualized a variety of participatory arts-based projects to make science and research more accessible to a non-specialist specialist audience. I have also conducted a variety of science communication workshops that included both academic communication and also public communication of science. I have also organized, conceptualized a variety of school engagement programs to make science fun and interesting. I've also really enjoyed working on developing public engagement funding models. What kind of funding can we provide for public engagement type of projects in the country? I've also really enjoyed building a variety of partnerships, not just in India, but globally, in public engagement. And more recently, I've been kind of dabbling in a little bit of research and policy work, which has been quite interesting as well. And it's a really interesting time to be in this space, also because I think globally the scientific community, governments are realizing that it's not just about taking science to the public, but really making them partners in the scientific enterprise. And that's why while formally science communication started as was called scientific literacy back in the day, and it kind of was a response to public's lack of scientific knowledge. At least that was the hypothesis, that since public lacks scientific knowledge, therefore they make poor choices and poor decisions, and so we need to improve scientific literacy. But over the years, as science and technology ecosystem worldwide is changing, and the advances are being made so swiftly that governments and scientific communities also realizing that you cannot be working in isolation from society, and that societal actors have to be part of the scientific advancement. And so now we're increasingly using the term public engagement with science, and you will come across, in fact, and you can see this change also in the science policy documents of Government of India. It was mentioned as scientific literacy, and in the most recent STIP 2020 document, which Siddharth was also was part of, and now calls it public engagement with science. This has also been a very interesting development, I think, in this space, also in our country. And you will, if you're interested in science communication beyond the Science Slam and beyond this webinar, you will come across, or you may have come across, a whole lot of different terms, a science communication, public engagement, citizen science, knowledge exchange, or outreach. And I would say that don't get bogged down by all these different terms and all these different jargon. I think what really matters is the purpose and the objective of why you want to take science to the public, or why do you want to engage public in matters of science and technology or health. And so again, all of these are different terms, but they all really are trying to make the impact of science more effective and more impactful, making science more impactful for society. And so you have all these terms that have been coined over the years in different parts of the world. And so, when I started out on my public engagement journey, as a scientist, you're trained to find definitions of different terms. So I was like, I need to know what public engagement means. I need a solid definition to anchor my work in. And I realized that, and I've come to realize now that public engagement really means different things to different people. And it is no real set definition for public engagement. There are definitions that talk about that public engagement is used to humanize scientific research and innovation. It's increasingly being used to define a two-way process of interaction between science and society with a goal of generating mutual benefits. It's also being used to say that we need to bring the widest possible variety of actors on the same platform so that they can interact with each other on matters of science and technology and co-create solutions together. It's also being used when you want to empower public to make decisions, especially vulnerable communities or communities that are completely disconnected with the science or the outcomes or the benefits that science offers. So it has also been used in that context. It has also been used in the context of just conversations in science that Arnab alluded to and has been spearheading this fantastic project or initiative, Chai and Why in Mumbai. And another very interesting definition is that that public engagement doesn't focus exclusively on science itself. It focuses on discussing problems that communities view as worth solving and information that people might need from scientists and potential risk, benefits, and consequences that new technologies or new scientific discoveries might be posing to people, and also as a way of building trust among stakeholders. So there are a variety of these definitions, and I would suggest you to look up all these definitions and not get trapped in just one. And this is primarily also because, when we go out as a scientist or as a science communicator out there to talk to a non-scientist, we have to consider that this process is very complex. It's not as simple as just taking science there and telling people that, okay, this is what I do, and you must appreciate it and you must say this is awesome. They will not understand. Like Arnab was saying, you have to explain the context, the relevance for your audience. And so you have to understand your audience very well. And that's what public engagement helps you do, is that you first study your audience well, and then you start thinking about how you may want to take science to them. And, you may have already heard about how climate change is heavily influenced by people's political beliefs rather than the scientific knowledge that is offered to them. So there are various such matters where, just presenting science or scientific knowledge or evidence is not going to be enough, because people are not just some empty jars that you can fill up with scientific information with whatever means you like. And I really like this kind of statement by Angela. So this is something that you have to bear in mind, and something that is at the core of public engagement. And these are, again, some models that you may have come across if you've been, following this field. The deficit model, which is probably the most popular model.
Sarah, sorry, I'm not sure, but your slide is not changing.
Is it changing? Where are you? Which slide are you seeing right now?
My experiments with science.
Oh no! Has it changed now?
Yes, thank you.
Okay, thank you. I'm so sorry. So anyway, so these were some of the slides that you may have. Is it moving now, Samrat?
Yes,
perfect.
Yes, now it is.
Perfect.
So sorry about that. I really don't know what's going on with my connection today. Apologies. So these are the three models of science communication, and the deficit model is the most popular one, which assumes that public's lack of interest or skepticism about science is because of their lack of relevant knowledge. And so by presenting science to them, you will be able to kind of spark that interest or kind of, get them interested in science and bust the myths. The contextual and dialogue model and the participation engagement model is something which is slightly more in depth. and takes into account all the different things that I mentioned earlier about the kind of various beliefs that that the public or your audience carries, and the kind of interest they may have, the kind of things they might care about. And so these models kind of take that into account. And this is really largely where public engagement with science lies. And because the idea really is that while you as a scientist go out and talk to the public about the cool research or the really important research that you're doing, it's also important for you to learn from that process and take something back with you to your research. And so that's again another very core element of public engagement, and something that you as a communicator, as someone trying to engage with public, needs to also think about. It's not just about sharing, but it's also about learning and listening to them. I really liked this little categorization of various roles that you see or you could take up as a science communicator or public engagement practitioner, which was put together by Milani et al. And you could be a broker where you create connections between your target audience and various actors. You could be a listener. You could be an includer, an enabler. You could be an educator or an entertainer. So there are a lot of different hats and a lot of different roles that you could play as a science communicator or public engagement practitioner, which it completely depends on the objective and the purpose of why you want to engage or communicate in the first place. And I'm very quickly just going to share some key elements that you have to bear in mind or that you have to pay attention to when you're developing a public engagement project. Is of course something that Arnab already mentioned, is why, what is the purpose, the objective, what is that you want to convey, what would be the intended outcome of this communication and engagement activity that you're undertaking, who do you want to target, and who are some other partners that you could perhaps work with. It's impossible for just you to be able to go out there and be able to influence non-science audiences. So you may want to consider folks who already have some sort of an in with the public or the communities or public groups that you would like to engage with. And what are some tools and approaches? So now when you know what is your purpose, what are some key messages that you want to convey, and who's your target audience, you can then think, then you will, the tools and approaches will become clearer. And it's also very important to think about timeline and also the timeliness of your public engagement project, and following which you have to assess, you have to evaluate whether what you did was impactful, useful, and reflect on your learnings, and also follow up, so that it's not just a one-off activity. And so here is just I'm just elaborating here what comes under purpose, what are some of the things you should be thinking about. It's very, very important to identify the purpose of the public engagement event right at the start. These could be the different objectives that your public engagement activity could carry. And this could be, do you want to inform your target audience? Do you want to consult with them? Do you want to involve them in the research that you're doing? Do you want to collaborate with them? Or do you want to empower them? And as you go from number 1 to number 5, you would notice that the power, influence, and involvement of publics and community increases, and so will be the intensity of your communication and engagement with them. So you have to be very mindful of this. And when we say public, we are usually very, very vague about public. I mean, public is so diverse. I mean, they could be, you could be talking about young adults. You could be talking about young adults in city or in a small town or a village. And so you have to be very specific about, and you have to break down who this public or who this target audience is going to be. And you may have your project may have primary audiences and you may have secondary audiences. And then you have to also think about, am I going to involve them? Will they be participating in what I do? Will I be consulting with them, collaborating with them, or will I be empowering them? And so your strategy would change depending on what is that you would want, or how you want to involve them in your project, or how you want to engage with them. And so once you figured out your audience, your methods and your approach will become clearer. For example, if you want to organize an event in a mall, if you want to engage with families, you will have to think of what are some of the places where you can find families, where you can find parents with children or guardians, or their guardians come more often. So you have to think of what would be the most appropriate platforms and tools that you could use to reach out to your audience. And these are, again, this is called the Welcome Trust Public Engagement Onion, and it kind of just shows you the range of formats and activities that you could take up depending on the purpose and the objective of your public engagement activity. And again, depending on whether you want to have a dialogue with the public, to whether you just want to share some information, your format is going to change quite drastically. And I think, like I mentioned earlier, think about partners, collaborators you could bring on board, because you may not have all the skill sets, you may not have all the resources needed to undertake that project. So it's not a bad idea to think of people outside of science, outside of research, who may be able to help you take your science or take your research to the public and meaningfully engage with them around it. And evaluation, I think, is something that we really undervalue in India, particularly. We think once we have done with the public engagement activity, we must have done a good job because we got a lot of claps and people were happy. But for you to really improve as a practitioner, it's important for you to evaluate how well you, the activity. And it's not just about how well, actually. It's not about judging your activity, but it's really kind of learning from it. And so evaluation is a very, very critical part of any public engagement project. And so when you start developing it, you have to already start thinking of how you would evaluate your project, what should be some of the questions and some of the areas that you might want to look at, in your evaluation process. And last but not the least, I think you have to be very mindful of the timeline and also the resources and funding you may need to undertake the project. So just, you have to outline the different stages of your project, how they will be done, who will be involved in them, etc. In India, we don't have a whole lot of funding for public engagement, unfortunately. So you have to obviously think of ways in which you could still pull off the project without making anybody work, for free or but also not spending too much money on the project. It needs to be quite, cost effective, and try to leverage your existing resources available, through your institution or in the place you are at. So just I'm going to share a couple of examples with you. So this is a project that I'm involved in called the Superheroes Against Superbugs project. And here we're trying to raise awareness around antibiotic-resistant infections. And we're really trying to help young children particularly understand why this is such a big problem and how their present and even their future will be impacted if this issue is not resolved. And they themselves then come up, after understanding the issue from their lens, from their context, they come up with various kind of awareness resources and ways of communication to take this message forward, in their own sphere of influence. And we have developed various formats of these workshops. We also leverage the WHO's World Antimicrobial Awareness Week to run a lot of events. And so this is just an example of a public engagement project that I've tried to show here. This is also another really interesting project that I always enjoy talking about, is Genome Adventures, where this clinic in Botswana, along with the Research Institute, felt that since they were working a lot on genomics and they needed samples of people, they felt it was important also for them to inform the general public about what is genomics and why is it important. And so they collaborated with, again, a whole host of people to develop a series of comic books. And there was a whole, the process of developing these comics was very, very participatory. And the scripting of it was very, very participatory. And it was not just one person putting together the entire comic. And so the outcomes, from what I understand, were also very, very good and very encouraging, because a lot of inputs had already been taken from the target audience and other groups. So this was also another very interesting project that I thought I would share. And this is just an example of how citizens can be part of various research programs and other types of programs. And there are, of course, a lot of very, very interesting citizen science programs out there that you could look up. And last but not the least, I just thought I would also share this program called the India Science Festival, which is something, again, I'm part of and I'm helping develop. And as the name suggests, it's a big celebration. It's going to be a big celebration of science. We'll be exploring a variety of science communication and public engagement formats at this festival, targeting a variety of audiences. So if you're interested, you can look up India Science Festival on Google, and there are a lot of competitions and other things that you can be part of as well. And so here are just some resources that I thought I would share. And I hope my slides are still moving and you can see what I have up on the slide that I've really enjoyed and I refer to quite often. And a couple of book recommendations at the end that you could look up if you're interested. And that's about it. And I really enjoy, I really like this particular doodle. And I have to say, this has been the biggest learning from me as a scientist turned public engagement practitioner, that, you know, we often think that people who don't understand science are people who are just not capable of understanding it. It's because we just do a really bad job of communicating it. And we also don't take into account that, you know, science is not the only thing on their minds. And, you know, their views, their ideas are shaped by a whole lot of other things that exist in this world. And so we really need to become better listeners, better learners as science communicators and public engagement practitioners. And that's why I have to say that I would never claim to be an expert ever. I would always be a student of public engagement with science. So that's all from my side. Please feel free to get in touch with me. I've put my email ID here. These are my social media coordinates, and all the very best to you for the Science Slam. And back to you, Samrat.
Thank you so much, Sarah. Very engaging talk, and a lot of information, also a lot of things I was not so much aware of. I think that was really great. Thank you for this. We also have another very interesting speaker with us today. Siddharth is joining us from Bangalore, and the title of his talk is Storytelling Hacks for SciComm. So that sounds very interesting. Siddharth, the floor is yours. Thank you.
Thanks a lot, Samrat. Sorry, my voice is a little hoarse today. Hello, everyone, and welcome. Really, really lovely to be here. And thank you so much, Samrat, Arnab, and EURAXESS for inviting me. So my name is Siddharth Bhattacharya, as Samrat mentioned. I'm a science communication practitioner, researcher, and now very recently also a teacher. Where at my parent organization at NCPS, I'm teaching 2 courses in science communication. And I'm actually really, really glad because Arnab has really covered a lot of the hacks that I was going to delve deeper into. And Sarah has really taken care of a lot of theory and research that I usually talk about at usually all my talks. So I'm really happy that's out of the way. And today I can focus on something really different, which is to talk about storytelling hacks, especially because the audience here is I'm hoping to sort of submit entries to the Science Slam, and I'm hoping this could be useful for them. So without any further delay, let me share my screen. Just let me know if you can see my screen. Is it good?
Yep.
Yep, Siddharth, we can hear you.
All right. So today, let's talk about the importance of storytelling and how we can sort of incorporate stories in our science communication efforts. And when I say science communication, I mean science communication, public engagement, outreach, knowledge sharing, knowledge brokering, all the terms that Sarah mentioned. You can think of these in a much more broader term. So I'm using science communication as a more encompassive term, which refers to all kinds of knowledge creation, sharing, and exchange activities that we might be engaged in, whether it's a scientific paper, whether it's a scientific talk, whether it's a science slam, whether it's a popular science article you're writing. You can use these storytelling hacks and techniques in almost any form of communication that involves science and beyond for your own purposes. Okay. All right. So why tell stories in science? Okay. So let's look at what are stories and why is it important to use them in science. So stories are nothing but, narratives designed to interest, amuse, or instruct the audience or reader. Stories are often a function or a way to bring people together. Humans have evolved in a way where communicating with each other and telling stories has been an integral part of our cognitive development. And if any of you know about mirror neurons, you also know that we can relate and empathize with other people because of a special kind of neuron, which are mirror neurons, which help us sort of empathize with people who might be experiencing a kind of stimulus or any kind of effect, which we may not be experiencing ourselves, but we can actually empathize with those people because of this. So stories in terms of human cognition are a very, very important way to communicate, to sort of, spark interest, to retain interest, and to make someone interested in what we are saying. And I think fundamentally, the purpose of science communication is also to try and make people interested in what we have to share, right? And to make our work interesting for them. So stories are sort of at the heart of why we do science communication. And they're absolutely, absolutely important and integral in trying to incorporate that within our psychom activities. So storytelling is a subset of stories, which is a way to share and learn ideas, values, and practices. Now, you must pay attention at the three things that I've mentioned there. It's not just ideas, which is your scientific facts or concepts. It's also about sharing and exchanging values and practices, right? So oftentimes we have a difference in value, which could be someone who believes in vaccine and someone who doesn't, someone who believes in climate change and someone who doesn't. So science communication is not just about one directional communication of information or facts or scientific concepts. It's also about learning about where other people are coming from, what is their background, what is their motivation, and trying to find common ground in a way that we can facilitate an exchange of knowledge, but also values and emotions and experiences, right? So science communication is much more encompassive than just sharing and exchanging knowledge. It also means that you try to understand emotions and values that other people might bring to the table. And that's the whole point of doing science communication, is to have that intellectual humility where you can sort of listen as much as you can talk, right? So although in a science slam format, you would be mostly talking, it's also very, very important to listen. And when I say listen, you can listen in many other ways, which could be looking at your audience, which could be looking at other visual cues that might be present, which might be other participants who might have covered something and just referencing them or giving them a nod. So there are various different ways of listening. And I think it's equally important as speaking or sharing things. Okay, so now let's look at storytelling and the 3 C's of storytelling, right? So whenever we are trying to craft a story, we have to look at 3 C's. So the first one is content, which is basically the concept or the idea and science that we want to communicate. The second one is context, where we try to understand our audience and where they're coming from, what is interesting to them, what is valuable to them, or what motivates them to come to our talk and listen to us. And the third one is connect, where we try to connect the content and the context of the audience in a way where it all makes sense, right? So for any successful storytelling interface or activity or idea, you really need to be able to connect the 3 C's, which are content, context, and connect, all right? And we'll circle back to these 3 C's of storytelling towards the end of the presentation today. So hold on, and I'll give you an example about this. All right, so far so good. Is everybody with me? Okay, I have no way of knowing, so if you can give a thumbs up, that would be great. All right. So another reason why stories are really, really important in science is because scientists themselves bear witness to unprecedented stories in science. So every major scientific discovery, whether it was Archimedes running out of the bathtub, whether it was the discovery of DNA, whether it was, the discovery of the fact that, the Earth goes around the sun and not the other way around. All of these are basically sort of full of drama, full of storytelling potential. And so whatever we do in science as scientists, we are always bearing witness to unprecedented stories, which probably nobody else has figured out or nobody else has sort of experienced, right? So there is a very, very inherent element of stories and storytelling, which is inbuilt within science. And that's one reason why we should be sharing stories of science with other people. The second aspect is that scientists themselves have very exciting personal journeys, whether how they became interested in science, how they decided to become a scientist, or what is the kind of journeys that they have on a day-to-day basis in their lab, right? So the process of science that they engage in, whether it's about doing an experiment for a year, it's about having multiple failures and trying to troubleshoot and finding a solution and having that aha, eureka moment in the end. So stories of science are full of tension, they're full of drama, they're full of successes and failures, and they're full of exciting ends, right? So So stories of science themselves are very, very exciting, and stories of scientists are also very exciting. So that's one more reason why we should be talking about stories of science. And last but not the least, that science is itself a field of pursuit of knowledge, which is really, really fertile for storytelling, right? So the ups and downs of science, or how human knowledge has progressed over the centuries, over the decades, over the months, over the years. And I think the timeline for progress of science is becoming shorter and shorter with the technologies we have today. But science itself is as a field of knowledge and inquiry and curiosity, is a really, really interesting sort of field and domain of knowledge, which is very, very fertile for storytelling. So these are some preliminary reasons why I think stories of science and storytelling in science is very, very important. But these are also ways where you can try and find ways of incorporating stories within your science, right? Oftentimes when we are doing a storytelling session, or we are trying to communicate our science, we can be baffled by what exactly to turn into a story, or how do I actually make my experiments in the lab into a story, right? So talking about your own journeys, talking about the ups and downs of your scientific discovery and journey, and talking about the field of science and the field of knowledge as it's progressing over the years, could all be very, very interesting ways of framing our stories in science. Okay. Right. So let's very briefly look at some storytelling principles. I think we're already running late, so I'm going to be quick at this, and I'm not going to talk a lot in detail, but I'll just touch upon one principle that I think is really, really important for understanding how to tell stories in science. Okay. So let's look at an example, right? This is a slide created by Dr. Mark Tullio Rossi of the ABT Science. And this concept of ABT was developed by Randy Olson, and just to give him a nod. So let's look at, so we are supposed to give a presentation, say a science slam, and we have to tell them a story. So how do you avoid the standard boring presentation? So a presentation is coming up. What kind of presentation are you going to give? The first way of giving a presentation is the standard list-like presentation, where you say, hello, my name is Dr. Smart, and I do research on XYZ. This is my first graph, and this is my second graph, and this is my third graph, and these are my conclusions, and you end the talk. That's the standard way of giving a presentation. Now, this is not really very, very, very interesting, because it's the and type of presentation, where it's a boring list of facts. It does not tell a story. It has no narrative structure. So it's probably not the way to go, right? Now let's look at one more way of telling a story, okay? A presentation is coming up. Which kind of presentation are you going to give? The engaging story kind, okay? So you say, hello, my name is Dr. Supersmart, and today I'm going to be telling you a story. We knew this, and we also knew this, but we really did not understand how this worked. Therefore, we did this experiment and found that this was important because XYZ, ABC, blah, 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 okay? Now, this is very, very different from the previous way of telling a story, because there is an and, but, and therefore, and that's the kind of presentation this one is. It's engaging, it tells a story, it has a narrative structure, right? Now, in this case, what you look at is the and, but, and therefore, right? Which is called the ABT. So and, but, and therefore. The and is nothing but setting up or sharing the background or the context. The but is basically introducing a conflict or a tension or drama into the story. And the therefore is basically a resolution of the conflict that was introduced later. Now, this and but therefore structure is nothing but a very, very basic building blocks of any narrative. It's called narrative structure. The ABT can also stand for agreement, contradiction, and consequence. It can also stand for setup, problem, and solution and action. But basically what we're trying to do is we're trying to come up with conflict resolution pairs, where you share a little bit of background, you introduce a conflict, and then you resolve that conflict, right? And this conflict resolution pair, or the and button, therefore, building blocks of storytelling, is fundamental to every and any kind of story. And these ABT structures are all around us, whether you look at films, you look at books, you look at television, you look at speeches, you look at ads, you look at journalism, everywhere around you, you can very, very easily find these ABT structures around you, okay? And I think these are fairly easy to sort of look at. I mean, think of any movie or any book that you have read, you will come across an ABT structure that they have followed in some way or the other. Okay. So with that, a little bit of, sort of principles of storytelling, let's look at a few hacks because we are short on time. So the first thing that I would share with you is to know your audience. So when you are developing your Science Slam presentation or the video, the first and foremost thing that you need to know is to know your audience, right? You need to understand not just the reason of why you want to communicate your science, but you also need to appreciate why are the audiences likely to be interested in listening to me. What's in it for them? What's their motivation of giving their 15 minutes of time to me, right? How can I help them sort of benefit out of this talk? Once you start thinking from their point of view, you put yourself in their shoes, the entire perspective of how you plan and think about your presentation or your science slam or video or science communication output changes fundamentally, because you're not just thinking from the point of view of what you want to do and what you want to achieve, but also from what the audience wants to know and what's in it for them to benefit out of my presentation or my video, right? And I think that is at the crux of what also Sarah mentioned about the dialogic and the participatory model of science communication. So it's to move away from a very unidirectional way of communicating about what you want to convey, and also understanding what the audience wants to listen and understand, right? So that's the fundamental difference that comes in. So the first and foremost thing in terms of storytelling hacks is to understand your audience, is to understand their backgrounds, their context, their motivations, their difficulties, their interests, their motivations, and so on and so forth. Step into their shoes, identify specific interests and motivations that they might have for engaging with you and your presentation. Try to tailor your story and its detail accordingly, right? What aspect of the audience's background, context, motivation can you sort of incorporate or build into or use within your storytelling session so that they are automatically hooked onto what you're saying, right? So how can you use instances and tidbits from their life and their context and their motivations to make your story more appealing, to make your story more relatable, to make your story more interesting and relevant for them, right? And once again, thinking of the 3 C's of storytelling, it's not just about content and context, it's also about connecting these things. So remember that connecting your content with the context of the audience is very, very important in any form of storytelling, okay? The next thing I think all of us have heard is to look hooks smartly, right? Now, hooks are nothing but ways of grabbing our attention and appealing to us emotionally. These can be images, diagrams, videos, it can be quotes, it can be questions or dilemmas, it can be analogies, anecdotes, games, props, activities, wordplay, humor that Arnab also mentioned, interactive websites. The list is really, really long. But I think one thing that I will mention at this point is to use hooks in a responsible manner. You need to be ethical about using hooks, because you cannot overpromise and sensationalize what you're going to share with your audience. So if you are sharing XYZ, you need to tell your audience that I will share XYZ, but I will not be able to delve into ABC because that's not within the scope of my talk or my presentation or my science slam video. And I think being responsible and ethical about the hooks we use and not over-promising and using hyperbole is very, very important, right? Now, just to give you an example, here's an XKCD comic. When you see a claim that a common drug or vitamin kills cancer cells in a petri dish, keep in mind, so does a handgun, right? So don't oversell, don't sensationalize, don't use hyperbole, and don't overpromise things that you cannot deliver, right? So use hooks very, very responsibly and ethically. The next thing that you can really use in your storytelling sort of activities is to signpost, right? You really, really need to be signposting to guide your audience. And this is something that Arnab also covered in his presentation, that you need to tell them what you're going to say, you need to tell them what you have to say, and then you have to remind them what you just said, right? So signposting and guiding your audience about what you're going to be, saying to them, what kind of a journey are you going to be taking them is very, very important. Now, an easy way of using signposts is to basically talk about benchmarks in your scientific journey, right? So you can say that we had this issue, or we had this scientific question that we wanted to talk about, but we did not know how this works. So we tried this, but we ran into a problem and we troubleshooted the experiment, and then this worked. And therefore we could sort of made a more broader level justification or contextualization or discussion or conclusion of what our results actually meant in the larger context. So you're also using benchmarks in terms of chronological sort of benchmarks in your scientific journey can also be used as a signpost, right? Another way of using signpost is to use ignorance, right? So in any story, you might have a character who is kind of going through the rigmarole of what the story is unfolding. And in the story, your audience might know what is happening, you might know, but the character in the story may not know what's happening, right? So using ignorance of your characters in the story is a great way of signposting, but it's also a great way of, sort of having letting your audience into a secret when the character does not know what's happening, but your audience knows. And it's a great way of connecting with them and making an emotional connection and appeal with them, where your audience starts relating to you, it starts connecting to you. And you can sort of use this also a way to signpost where your story is going. And last but not the least, a very obvious thing is to take them on a journey and tell them that you're taking them on a journey. Keep reminding them that you have progressed incrementally throughout your journey. And when you reach the end of your journey, you tell them and share a conclusion that this was the journey we went on. If you would like to go on more tours and expeditions and mountain climbing sessions with us, please let us know and I can talk to you later. But for today, this is the end of our journey. So signposting and letting people know where they're going and where they've reached is very, very important in any kind of story. Okay, can anyone tell me what is this? And if you're not able to unmute yourself, can you write in the chat box, what is this? Any guesses? I'll give you 30 seconds. Take a guess about what is this. Okay, I have a feeling that I cannot see what people are writing in the chat box, but that's fine. Right,
I can read it out for you. I can read it out for you. Jargon says Fibonacci sunflower, Nalikanta says illusions, anonymous sunflower, Anupama sunflower, Preeti sunflower.
All right.
Okay, they're coming as flower, sunflower, macro, flower.
I get it, Arnab. Thanks a lot. Thank you so much. Yeah, all right. So I think this is a sunflower and most of you got it right. And that's really, really good. But a lot of people do not get this. And the idea behind this is that if you start with the zoomed in detail of a macro image of a sunflower, you may not be able to understand what it is. But if you start with a more sort of more wide angle picture of a sunflower and then go into the sort of the seeds of the sunflower, it makes a lot more sense. So the point that I'm trying to make is that you need to contextualize the bigger picture of your science and connect it to society, connect it to its applications, connect it to why it's important for the audience to be listening to your science, instead of starting with that we looked at P53, tumor suppressor gene in so-and-so cell and we wanted to mutate this and we wanted to create a knockout. That does not really work because your audience has no idea what you're talking about. And even if they do, they will lose interest very, very quickly. So you really need to start with the bigger picture and then you need to go into details gradually, incrementally, as you progress through your storytelling journey. Okay. Another thing about keeping your story moving is to cherry pick your anecdotes, right? Now in science, we often say that you cannot cherry pick your data and you cannot choose data based on what looks appealing to you. But when you are storytelling and when you're doing science communication, you actually don't need to convey the entirety of your scientific journey or every experiment you did. Even when you write a paper, even if you present a talk, you don't share all the experiments you have done, right? You always pick some of the relevant ones which are important. In a very similar fashion, when you're doing science communication or when you are sort of telling a story about your science to different kinds of audiences, you really need to cherry pick the anecdotes that make the most sense, that will sort of help you tell the story in a way that you want, and that will help you progress and incrementally move your story forward rather than trying to fit in the entirety of it. As scientists, we are sometimes really, really obsessed with, being complete and accurate and trying to convey the entirety of the accurate information. But sometimes when you are doing science communication, knowing what not to talk about and leaving out the most important things is actually, leaving out the things that don't actually matter is actually way more important than including everything, right? So do cherry pick your anecdotes and don't forget the ABT structure that I just talked about. Another thing about telling stories is that you do not need to tell your scientific story in the way that it actually happened. You can actually use non-linear timelines. So you can start with something in the middle where you had an interesting anecdote to share or some experiment didn't work. Then you can come back to the beginning of the story of your science about how the scientific story came about or how did you start working on this project. And then you can come towards the conclusion and then you can tie it back with the story that you started with, right? So you can take all these creative liberties of, using a non-linear timeline or framing your stories within stories, just because it makes your story much more appealing and interesting. And if you look at any book or any movie that you have watched, non-linear timelines are very, very standard. They happen a lot of times. And if you want examples, just go watch any movie or any sort of book that uses this. The last thing that I will say about keeping the story moving is to use harmonic oscillations between storytelling and the science. So as scientists, we fall into the trap of sort of explaining all the basic foundational fundamental concepts of science and then talking about how the journey happened, right? But sometimes if you're trying to explain all the science in the beginning or towards the end, it can be too much for the audience to absorb and, digest, right? So what you need to do is you need to have an harmonic oscillation between explaining the science and the scientific concepts and, clarifying scientific ideas and concepts and going back to the story. So storytellings could be an overarching arc where you are engaging your audience in a story, but every now and then between your story, you can, break out from the story, explain a little bit of the science or a scientific concept that is important for the story. And you do this in bits and pieces. So as long as you keep harmonically oscillating between the story and the science, it is much more appealing. It's much more digestible. It's much more interesting. And the audience is more likely to stay with you till the end of the story and not lose interest or not get saturated, right? So harmonic oscillations in your storytelling are also really important. Slaying the jargon dragon, right? Now we're all aware of a lot of scientific jargon. If you are a biologist and you attend a physics talk, or if you're a physicist and you attend a biology talk, you can very easily realize that there's a lot of technical terms that we use that we call scientific jargon that crops up everywhere. And this is not just true for people with and without scientific training. It can also be true within the field of science when one physicist attends a biology talk and vice versa, right? So it's very, very important to realize that there are a lot of technical terms in our scientific talks and presentations that we might be using, and it's very important to make sure that we stay clear of them, or at least explain them when we have to use them. So try and use everyday language as much as you can. Try to be careful about terms which mean different things in different contexts. So for example, when you say a cell might mean very different thing in biology, and it might mean like a prison in everyday language, right? So also be careful about words that mean different things in a scientific term versus a non-scientific context. So use everyday language, explore complex ideas. Sometimes when you are explaining your science, you have to use complex ideas, but what you can do is you can build up the complexity, right? So you Lego the complexity. Just like you build a Lego block or a Lego set, you start with one layer of complexity, you keep adding a little incrementally, and that's how you build complexity, right? So do not shy away from explaining complex scientific ideas. Do not assume that your audience is not smart enough to understand. It's just that you need to build the complexity in an incremental fashion and go a little bit slow. Another thing that happens very often is that we use a lot of abbreviations that we are familiar with, but our audience may not know about. So it's very important to expand your abbreviations. You can use abbreviations, but expand them, repeat them a couple of times in your talk, and then start using them as abbreviations. Lastly, proofread and edit ruthlessly as much as you can. Oftentimes when we write something, or we make a video, or we make a science slam, we often forget a lot of things, or we might overlook a lot of things. But if we record ourselves and proofread and edit and rewatch what we have recorded, we can ourselves come up with a lot of flaws and things that we can improve. Another thing that you can do is to share it with your friends, share it with your family, share it with your grandparents, and see if they don't understand anything, right? So this is a very easy thing to do, but I think it's underrated, and people don't use proofreading and editing as much as they should. Another thing, when you're writing stuff, you can use tools like the de-jargonizer tool or the Flesch Kincaid readability test. There are lots of resources on the internet which can help you simplify scientific jargon. And the internet is your friend, so feel free to search for these and use these as and when necessary. I'm going to skip the comic here in the interest of time and move on. So another thing that I think is really, really important in storytelling is to use metaphors and analogies. Now, the electricity, if we think of electricity, we often think of, there is the analogy or the metaphor of electricity and a water pipe system is so strong that even though the flow of electricity is actually opposite to what we feel intuitively, we still hold on to our intuition about the direction of electricity flow, because the metaphor of water flowing in a pipe is so strongly correlated with our understanding of how we visualize or conceptualize electricity as a scientific concept that is difficult to get out of it. And we really have to work hard against doing this. And I'm sure everybody has experienced this when they first start learning about electricity in high school, right? So things like pipe being analogous to wire, pump being analogous to battery, water, of course, being analogous to electricity, pressure and voltage, narrowness and resistance, flow and current. I mean, I can go on, but the point is that this metaphor and analogy of an electric wire and a water pipe is so strong that we actually have to do cognitive work to get out of it. So that's the power of metaphor and analogy in science. And you should be using metaphors and analogies, but you should also be using them carefully. There are lots of caveats when you use metaphors and analogies. So you should use metaphors and analogies because they make your science more accessible. They make it more easier to relate. They provide a more physical, tangible, cognitive model to map onto your abstract scientific concepts too. But they can also have limitations, and it's important for us to flag those limitations when we are using these metaphors and analogies. So one more cartoon by my friend Matthew Farinella. So in conclusion, just like microscopes, metaphors enable scientists to visualize the invisible, bringing into focus useful details by blurring others. So metaphors are nothing but mental models which allow you to focus on specific aspects or characteristics or details of a scientific concept while you are keeping aside the rest of the details which might confuse your audience, right? You can come back to the rest of the details, but metaphors allow you to focus on one important trait or characteristic of your scientific concept while keeping the rest of it aside. And I think that is the reason why metaphors and analogies are really, really powerful and really useful. So use them as much as you can, but use them responsibly and use them carefully. Okay. Last thing that I would like to share before I end is this idea of balancing accuracy and accessibility. I think as scientists, we always fundamentally struggle with trying to sort of retain scientific accuracy in all our science communication efforts and trying to sort of make sure that our SciComm efforts are also accessible, they're entertaining, they're appealing. And this push and pull or trying to balance between accuracy and accessibility is something that we all struggle with. So here are some tips about how you can do that. So my mantra for doing this is to aim for a representation of the truth that draws your audience in, but does not mislead them, right? So you distill your science, but don't distort your science, right? And this can be a difficult balance to achieve, but it becomes better and it comes with practice. So I guess there's no way out of it apart from doing more and more science communication and practicing. But the idea is that you should distill your science, but not distort it. And I think that's the line that I like to draw when it comes to balancing accuracy and accessibility. Now, a good example of balancing accuracy and accessibility is maps, right? When you are looking at a map of, say, crop distributions or rainfall patterns across India, you're not looking at the state lines, you're not looking at the topography of different places in India, but you're just looking at what crop is grown or what kind of rainfall is happening in which part of India, right? So maps are actually a great example of selectively focusing on one kind of information while letting your audience assume or take for granted the rest of the stuff, right? It does not mean that Indian state boundaries have disappeared. It's just that it is understood by your audience that maps are a model for you to sort of share one particular aspect of the Indian crop distribution or Indian rainfall patterns or Indian topography, while ignoring the rest, right? So maps can be a great way of selectively sharing information without distorting it, right? Now, another example could be...
Are you selectively coming towards the end?
Yes, this is the last slide. I'm almost done. Cool. Yes, sorry. And another example could be games, which sort of build up complexity just like Lego blocks. So with that, I think I'll skip this and I'll end on this note that science communication can be seen as a process of distilling the most salient information from a complex body of work into the most concise and compelling story possible for a given audience. So as long as you can find the most compelling story for an audience and you can distill the most important information for them, I think your science communication is successful and it is a good sort of SciComm activity. We often think of, in science, we say the plural of anecdote is not data, but the plural of anecdotes can be engaging science communication. And I'm going to leave you with that question to think about it. With that, I'll end my presentation. Thank you so much.
Thank you so much, Siddharth. A very, very interesting talk. And I know that we will receive your slides and we can share them with the audience. You know, then you can also go through them again. And I think Siddharth made a very good presentation. Now we're quite late, but I think it's been super fascinating and interesting so far. But we move on to Geneva, Switzerland, where our dear Priyanka is waiting, and she will tell us now her story. We will write the story of science communication as a professional path. Thank you, Priyanka.
Thanks, Amrat. I will quickly begin, and already with Arnab, Siddharth, and Sarah's talk, this sets up mine quite well, because as you can see, they've talked about the tips and tricks, and Sarah's talked about how you can the amount of flux that's going in for beginning the research and development and furthering science communication. And I will talk about how you can take that plunge. I will just quickly check if you are still seeing my presenter view or my main view.
We can see
your main view.
Okay, perfect. Thank you so much. Yes, so I will share the portfolio, how your portfolio can look like. So treat this as a quick step-by-step guide, and later you can talk to me about the details or ask me for links or etc. Right now is a quick guide, and feel free to ask me questions about this later. How I will tell you this is, I will show you how your portfolio can look like. And this I will do by sharing my own scattered portfolio. Then I will talk about what sort of scope you have in science communication. Of course, many of you joining are already working in science or might already be working in science or science communication. But those of you who are just beginning and are interested, I can show you what sort of roles are available and what sort of horizon you're aiming at. And lastly, I'll talk about how you can begin this journey. So once you're interested, which congratulations, you are interested since you're here at the webinar and you've made your first step, but how to carry on this interest? We can talk about that. So without further ado, I begin a portfolio. And as I said, I will to show how your portfolio may look like. Again, there are many ways of doing this. One of them, which I used to use for applying for jobs, because I came from a pure science background. I was doing genomics and metagenomics and zoology. And then I got to know about science communication as a field, and I became very interested. And then I had to establish myself in trying to find SciComm jobs. So I had made this portfolio, and you could do a similar one to stand out or present your work in a concise manner. It takes the place of a CV, but it helps you connect with your recruiter a lot sometimes. So in this case, what your work portfolio can have is your educational qualifications. Much like your CV, it can have your skills and strengths, experience, latest roles, work samples. And at the end, I like to add this, which is possible contribution, which is a section customized mainly for the place that you're applying to. So you tell them how you can contribute to their specific job role. And for example, I have put my educational qualifications here. Then I give a glimpse of some of the companies I've worked with or I've had projects with. I usually like to go over each of these, but just to give you an idea of what a portfolio can look like. I don't need to go through this right now. Of course, feel free to ask me any questions about any of these experiences. So just a brief is, one, I was working in Gujarat with Vikram Sarabhai Science Center, which was hugely rewarding, because we were going around talking to people in lots of schools in India and training them on how to make science accessible for students, or science experiments fun and practical rather than them being rote. So stuff like this you can put on your experience sheet. Then these are some of the latest roles that I have done. So this gives more of a broad spectrum of the projects that I've done in Belgium, some projects in London. One of them was because I was studying in London. And then after that, I kind of taught some science communication courses at King's College, then did other few internships. And currently I'm working at CERN in Geneva as a communications and marketing fellow for their knowledge transfer department. So I help talk to people about how CERN, the European Organization for Nuclear Research, is taking its technologies based only for physics out of that physics realm and having applications in the medical field or aerospace. And my job is to talk about that. Now, in the portfolio, it's always handy to add some work samples, and the benefit of having a non-linear structure for your CV is that you can add visuals that kind of entice your recruiter more. And these are, again, so either if you are a writer, you can add your writing samples, or if you're applying for designs or science illustrations, you can also add samples of your science illustrations or links to thereof. And this one is what I was saying, is a slide that you can add for how you can help, how you specifically can help the person or the job that you are applying for. And what it means is that it not only gives you a chance to highlight your skills, it also gives you a chance to connect with the recruiter or the person or the job that you are applying for. Now, this was a fast-forwarded portfolio. And now I can say that where you can use this portfolio for, or these portfolio tricks for, essentially. So the scope of science communication roles is not just to the normal science journalism or the immediate science lab thing that comes to mind. A lot of us think of writing articles, but it's not just limited to that. When you're working in SciComm, you can do projects and events. You can handle the communications management of a team or of a science lab. that wants to engage with the public, or let's say has a policy development project, and you can contribute to that. One of your specific roles could be you handle the social media. At CERN, we have a special social media wing dedicated to communicating science. And in today's world, it is a massive field because every one of us is either online or on social media. So digital campaigns could be a specialty. If you want, you can also apply for niche roles such as audio and video editing or illustrations and graphic designing. Some of the other ways you can contribute is also policy and research. Like Sarah was talking a lot about the Science Policy Forum, and I think Siddharth also said about it, and the policy documents I think are available in the chat right now. But you can contribute with your abilities to research facts and develop projects or studies to research the trends in science policy or any other such related area, and contribute to this behind the scenes of furthering science communication and science communication policies in India or somewhere else. Now that I have given you a brief glimpse of the multitude of possibilities you can have, now I want to take you on a section of beginning your journey. As I said, congratulations again, you are here. So you have already taken the first step in starting your journey. I would like to use the analogy of a story, and let's take the classic. When I think of storytelling or journeys, I think of the Lord of the Rings, The Fellowship. And those who are not familiar with it, like all good stories, the story of this is also very simple. There is a person who has found a ring, which the ring is in this context of one ring to rule all rings. And then they go on a journey because this ring needs to be destroyed, because fallen in the wrong hands, it can wreak havoc. So what does this have to do with science communication as a professional path though? Right now, your interest is like the ring. The journey you will take is the journey that will become your professional path. It will be an unexpected adventure. Many of you might already be in science, or even if you're not from a purely scientific background, you can be a communications person, or you could be a person in history or reading political science. And you want to explore how you can connect these two worlds of science and communication. So you can try to educate yourself, but in doing so, you will explore many options. None of your path will be the same. It's not the route of, okay, 10th class, 12th class, BSc, MSc, PhD, and more. You will have a journey of your own, and it will be an adventure. And finally, in case of our analogy, the objective was to end evil reign. In your case, it will be your final goal. So as I said, if you want to be a person who's amazing at science journalism, that will be your objective. I want to be a person in journalism communicating about science. Or it could be you wanting to make amazing scientific documentaries in Discovery Channel. So that will be your end goal. But to do this, what I like to do is start backwards. So start with your objective. Start with what you want to be, and what you can do is go to EURAXESS portal actually, and you can see a lot of opportunities available, a lot of job descriptions, let's say, and this you can do in LinkedIn or any other portal where you come across jobs that you want to have, and start from there. See what is needed. So in your case, it will be any of these many fields that I said you could apply in science communication. And then you start backwards of trying and exploring these options. In this case, you will experiment. As I said, you will try out new things, you will attend workshops, seminars, or competitions, and you will network. So this seminar and this webinar as an example already, once you come here, you learn about these tips and tricks like Arnab, Siddharth, and Sarah shared. You will learn more. You will be able to network. So even if you're not able to follow the entirety of things right now, you can always reach out to these people and build your connections to know more and more about the things that are outside your horizon. So you broaden your perspective. And then you have to put in the work. What I mean by that is, like any journey, it will be an adventure. And in an adventure, there are the ups and there are the downs. Not necessarily downs as such, but this is the hard work you have to put in, which means that you will have to develop your skills. The easiest way to do is to practice, 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 keep attending these. There is subliminal, you will subliminally absorb a lot of the things, but then you also have to go out and practice. So try engaging in little articles to your friends, or in your area's magazine, or writing to journals. But if you do not want to do it, if you don't want to take that step, you can already start going to workshops where you can practice. You can apply for jobs, even if you're not ready to apply for science communication purely as a career, you can do part-time writing work, or you can see what a job interview would demand of you. And interviewing itself is a skill. And then you can reach out to people in this field, as I said, and as you keep reaching out to these people, as you keep reaching these seminars, you will keep learning more, and then you repeat. So this was the unexpected journey. And finally, we come back to where we are right now, which is your interest in SciComm right now. So this is where you are, and you can begin your journey. To recap, I told you about the portfolio. Again, you will have these slides available, so always feel free to take inspiration from it. These designs are my own, customized based on some Google slide designs, but feel free to take those, or you can experiment on many other websites. I use Canva or Adobe InDesign, but nowadays, if you want, you can also ask me and I can send you a link later. The scope I shared with you, again, this is not the limit of the scope. There are many other opportunities and availabilities, what you can do or how you can contribute to science communication. And again, I wish you a good luck. Now, I wish you good luck to begin your journey now that you're here. And that's it from my side. Thank you.
Thank you so much, Priyanka. Really exciting, wonderful journey. You showcased us your own example, and I think it's very inspiring for those of you who are also thinking to embark a journey as a science communicator. Now, last but not least, we have a very, very special guest with us, Soumya. She is a PhD. No, sorry, she already is a PhD, Dr. Soumya now. Like last time, I think we met, Soumya, you were still completing your PhD, but now you are Dr. Soumya, and you're now a research fellow at the CSIR National Institute of Oceanography in Goa. And Soumya is also the winner of the EURAXESS Science Slam 2020. And the 2020 Science Slam was a novel, tricky one, because it was the first time we did the Science Slam finals virtually, and the performers had to send in as a video. Prior to that, we used to do it live on stage, but we had the pandemic period, so we had to move online. And it was a big challenge for us, but also for the finalists, but they did an amazing, fantastic job. Soumya was just, mind-blowing in her performance. Now we're back again to live on stage, which we're very happy for this year, but still we wanted to have Soumya here with us to tell us a bit about her journey as a EURAXESS Science Slam finalist and a winner. Like, what inspired you to participate, and how did you experience your journey as a science slammer? Thank you, Soumya.
Am I audible, Samrat?
Yes, you're audible.
Okay, thank you. Yeah, hello everyone. First of all, thank you, Samrat, for having me here. And like Samrat mentioned, I'm Soumya. I won the Science Slam in 2020. So like he mentioned also that during our time, the slam was mostly online, but this year it's going to be offline, particularly the final round is going to be offline. So that's exciting. So despite that difference that we might have, I still hope that I'll be able to share some of my experiences and they're going to be useful to you. If I think back about the initial days when I was deciding about participating in the slam or not, I remember being a little apprehensive and a little doubtful, because I wasn't really sure if I'd be able to, combine my research with other more creative aspects such as singing or dancing. I wasn't really sure if I'd be able to do it. But nonetheless, I participated in the slam, and it was a great experience because you get to learn a lot from Arnab, from Priyanka, and even other fellow participants. So the best part about it was, you don't really need a background in science communication. You can come with whatever skill set you have, and then, you can build it on from there. So if there are people out there who are still doubtful about participating, I would say a good place to start would be to look at the EURAXESS India YouTube page. So there you would have access to, videos from previous year's participants. You can look at what a science slam is. You can try to understand what are the various methods that people are using to, communicate their research out of the lab. And apart from that, even YouTube is a great resource. So what I did was, look up to some of my favorite science communicators, somebody like ASAP Science, or, It's Okay to Be Smart. So you can also go out, look at these people, and you try to identify the methods that they're using to communicate their ideas out of lab. So that's going to be a good starting point. Now, once you have decided that, okay, I'm going to do it, I think the initial challenge that I faced was, to decide what would I base my slam on? What would be the topic of my slam? So back in 2020, I recently published a paper, and I was like, okay, I'm going to do it on this. But, very quickly, I realized that that was going to be a huge mistake, because the way we researchers communicate science is very different from how, a general public does it. So we researchers, and I'm sure a lot of you here would be aware that when we write papers, we do it in excruciating details. We talk about the methodology that we used. We talk about the positive results or the negative results that we found, because for us, even the negative results, they're like a cautionary tale, which tell us that, okay, don't do this in future. So we try doing that. But somebody who does not have a background in, my field, or somebody who's from some other field, is not going to sit through those details. That's going to be off-putting to, somebody who doesn't have a background in my field. So yeah, what I would say is, pick one concept or just a few interesting results rather than picking, 10 different things. That way you might end up cluttering your video, and, you're going to be confused yourself, and it's going to convolute the message you're going to put out. So, keep it simple and keep it really short and simple. Like, don't try to include a lot of different things. That is something that helped me also after I decided not to put everything from my paper into the video. Now, coming to the content of the video, so this is something that other speakers have also spoken about, and something I think which is one of the most important things, which is to, get rid of the jargon. That is, if you have any complicated scientific terms in your slam, get rid of it, because people are not going to understand it. They're not going to relate to your slam. They're not going to relate to what you're trying to say. So, break it down, do it like you're explaining something to a kid. So while I was preparing for the slam, one of my friends, he introduced me to something called the Feynman concept, which is named after the Nobel-winning physicist Richard Feynman. So what it says is that if you're trying to, communicate something, bring a 12-year-old kid and try to explain that to the kid. And if you succeed in doing it, you've succeeded in two ways. So first, you've excellently communicated what you're trying to do. And second, even you understand, like even you have a really good understanding of your subject. So slam is, it's not a one-way process where you're just trying to put your science out of the lab, but it's also a two-way process. It's an exercise where you can gauge how well you understand your subject. So, when we try to use complex, complicated terms, that shows a lack of understanding on our part. So just break it down as if you were explaining things to a kid. So if you can't find kids around you, probably, get your family, friends, people from other labs, people from other backgrounds, and perform your slam in front of them. And using the feedback, try to find problematic areas in your slam, and then try to break them down. So I made my slam on phytoplankton, which are these microscopic organisms that are found in almost every water body on Earth. And diatom is a kind of phytoplankton that is found in the ocean. So this simple connection, where diatom is a kind of phytoplankton, I thought that was not worth mentioning because it's so basic for me when I study marine science. But when I performed the slam in front of my friends, one of them pointed out that, okay, your slam was about phytoplankton, but why did you keep talking about diatoms so much? And that is when I realized something might be trivial to me, but somebody who doesn't have a background in the field is not going to understand what I'm trying to say. So, a good way to get rid of identify these small glitches in your slam is to talk to people who come from different backgrounds. Try to understand where they're coming from, what they would understand and what they wouldn't understand. So yeah, that is one good way. And also, once you've identified the small glitches in your slam, the areas that are difficult to understand, some ways to break that down would be use pictures to show what you're trying to say. If you're trying to explain a process, maybe use an animated video or a short video. Another thing that really helps is, pick a concept from the lab and then try to relate it to the everyday things that we do. So if you're talking about magnetism, maybe you could talk about the appliances that we use at home that, apply magnetism and that work on magnetism. Like I was talking about phytoplankton. That is microscopic. Not a lot of people have seen it because people don't really have microscopes lying around. So what I would do is probably show them a picture. So it helps them visualize things better. And also, because phytoplankton is something that fish eat, and fish is something that a lot of people have seen. So when I talk about fish in relation to phytoplankton, people can relate to it a little bit better. And then it becomes easy for me to establish when I say that, okay, if you affect the phytoplankton, you're going to affect the fish because the fish eats them. So that is like a way I think I was able to improve my slam after, people identified the problems with it. So yeah, a good way would be to, do it in front of your friends, do it in front of your family before you submit your videos. Now, coming to the extracurricular skills. So yeah, extracurricular skills and like singing, dancing, drawing, and other things. It's a great way to, make your slam more attractive. And if you can do them, you should go ahead and do them. But one important thing that I would like to mention here is that, if you think you're not comfortable doing it right now, or if you think that, you're not good at it right now, probably don't do it because, the primary goal here is to communicate science. And even if you just switch on your camera, talk about it clearly, enthusiastically, I think the judges and even the audience is, going to resonate with that passion. So if you can do it, that's great. Go ahead and include it in your slam. But even if you can't do it, I don't think that's a huge problem. You should be able to talk about it clearly. And I think that's a job well done. Like, don't let it prevent you from participating in the slam because this is a great opportunity that you wouldn't want to miss out on. And again, at this point, probably the initial stage, I would say, don't worry about, your production quality also too much. I think as long as you're visible, as long as you're audible, I think that should be great. And later on, Priyanka and Arnab are going to help you on when they do the science workshop, science communication workshop. But just some of the tips that they told us while we were making our videos would be, when you're shooting your video, try to have the source of the light in front of you rather than behind you, because that's going to cast a shadow and probably make you a little less visible. And something else I remember is, okay, so when you're performing your slam, maybe, stand up while doing it because that gives you a little bit more movement. You're a little bit more freer and you appear a little bit more confident. So instead of sitting down and doing it because it's going to restrict your movement. So yeah, those are some of the things that I remember. And yeah, I hope I've been able to, inspire some of the people, particularly the people who were on the fence about participating in the slam, because it's a great, it's a great opportunity. And even if I've not been able to inspire you, I think the prize, which is the trip to Europe, should be a great inspiration in itself. And it's more than just being a fun trip. So if you're a master's student, if you're a PhD student, you can go out and build your network. Master's students can look out for potential PhD supervisors, and PhD students can look for potential postdoc supervisors. So particularly when you're applying to a famous lab or great scientists, they are less likely to reply to you because they receive a lot of mails on a regular basis. So if you have a little bit of a backing from EURAXESS, they're more likely to reply to you and reach out to you. So why not have that extra push while you write the email to them? So yeah, it's a great way to build your network, enhance your research output that you do later on in life. Yeah, and I'm looking forward to receiving a lot of looking at a lot of videos that you make this year. So all the best for you. Thank you.
Thanks so much, Soumya. Wonderful. Like you really give a very inspirational testimonial. You told us, like how you approached, the challenge of making a short video and submitting it for the EURAXESS Science Slam, and all the, like tips and tricks and advices I think are very, very valuable. And now we are at the end. We have a bit been over time. We stretched the time a bit, but I think it was totally worth it. I would ask the others also to put on back, the other speakers to put on their camera so we can see all of you again. Thank you so much, all of you, for joining. Now the ball is with you, dear audience. If you really want to participate in this exciting competition, you have still time. The deadline is 9th of October for submitting your video. And we're really hoping to receive many. And we're much looking forward, to viewing them and to having some good time and fun watching your videos, which you hopefully will start producing now. And if you have any questions, you can always reach out to us at india@euraxess.net. You can reach out to our dear moderators, Arnab and Priyanka. You can reach out to Soumya, to Sarah, to Siddharth, if you have any questions regarding science communication in general, but also about the Science Slam. With this, I would say thanks so much, everyone. Unless one of you guest speakers has a final word to say, now is the chance before I end this webinar. Arnab. Priyanka.
No, it was great. Thank you. Thank you so much.
Okay, great. Okay, we're waiting for your videos. Take care. Thank you so much, everyone. Thanks again. Bye.
Bye, everyone. Bye. Thanks, Samrat.
Bye.
Thank you. Bye.
Thanks, everyone. Bye-bye.
Bye.
Bye-bye.
Bye.